In the preceding lesson, we defined a circle in terms of a set of points. In this lesson, we shall give names to other sets of points or curves and derive the corresponding equations. As in the case of a circle, the equations will be of second degree or quadratic in two variables. All the equations, with a few exceptions, define relations sum, of which are also functions. The general quadratic equation in x and y may be expressed in form of ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. The graph of a second degree equation in the coordinates x and y is called a conic section, or simply a conic. This designation derives from the fact that the curve can be obtained as the intersection of a right circular cone and a plane. In this lesson, we will be learning more about your conics, its definitions and general forms. We will also tackle the first form of our conic, that is your parabola, and we will discuss about its equation in standard form, and also the reduction of the general form to your standard form. Conic section is the path of a point which moves so that its distance from a fixed point is in constant ratio with its distance from a fixed line. The fixed point is called the focus, and the fixed line is called the directrix. If we consider the distance from your point F or your focus going to point P, that is any point on our conic section, and your L to P as the distance from your directrix going to that point, the ratio of these two is called E. The fixed ratio is the eccentricity of the conic section. The conic section falls in three classes according to their eccentricity. If the ratio of the distance from your focus to a point and your directrix to a point, or your eccentricity, is less than 1, your conic section is an ellipse. If the eccentricity is equal to 1, the conic section is a parabola. If the eccentricity is greater than 1, the conic section is a hyperbola. Let us also familiarize the important entities of our conic section. The axis of symmetry is the line through the focus perpendicular to the directrix. This is your axis of symmetry. Latus rectum, the line through the focus parallel to the directrix, with a length 4 times the distance from the vertex to the focus. This is your latus rectum. Going back to our theorem, an equation of the second degree represents a conic section, and conversely, ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. The parabola is defined as the conic whose eccentricity is 1. It is generally represented by the equation ax squared plus dx plus ey plus f is equal to 0, or cy squared plus dx plus ey plus f is equal to 0. Equation of a parabola. Here we will learn about the parabola with vertex at the origin and the parabola with vertex at hk. Parabola with vertex at the origin. In our figure, We consider the distance from the focus to a point as d. Since your parabola has an eccentricity of 1, that means the distance from your directrix to the point is also d, giving us the distance from our directrix to a point equal to y plus a, and the distance from the point focus going to your point in your conic section equal to square root of x minus 0 squared plus y minus a squared. Squaring both sides yields y squared plus 2ya plus a squared is equal to x squared plus y squared minus 2ya plus a squared. Simplifying our equation will give us x squared is equal to 4ay. Thus, the standard equation of a parabola with vertex at the origin is x squared is equal to 4ay, where your a is the distance from the focus to the vertex, and 4a is the total length of the lactus rectum. We see that changing the sign of a, in effect, reflects the graph through the x-axis, leaving a new graph congruent to the original one. Let us remember that in our figure earlier, your a is the distance from your directrix going to the vertex. But since the eccentricity is equal to 1, that means the distance from your directrix going to your vertex is equal to the distance from your vertex going to your focus. Now, the equation of a parabola with vertex at the origin and focus at coordinates 0a is given by the equation x squared is equal to 4ay. The equation of a parabola with vertex at the origin and focus at 0, negative a has an equation of x squared is equal to negative 4ay. The parabola opens upward if the value of your a is greater than 0 or that is positive, and it opens downward if your a is less than 0 or that is negative. We can, of course, have the focus of our parabola either to the left or the right of our Cartesian plane. The equation of a parabola with vertex at the origin and focus at a0 has an equation of y squared is equal to 4ax. For parabola with focus at coordinates negative a and 0, the equation is y squared is equal to negative 4ax. The parabola opens to the right if your a is greater than 0 or that is positive, and it opens to the left if your a is less than 0 or that is negative. We now consider a parabola whose axis is parallel to, but not on a coordinate axis. Here, the vertex is at hk, and the focus at h plus a and k. We introduce another pair of axes by a translation to the point hk. Since the distance from the vertex to the focus is a, we have at once the equations. With axis parallel to OY, if our parabola opens upward, the equation is x minus h squared is equal to 4a times y minus k. If it opens downward, x minus h squared is equal to negative 4a times y minus k. As you can observe, the same theorem applies. If the location of our focus is in the positive axis, the value of our 4a is positive. And if our focus is located on the negative side, the value of our 4a is negative. For parabolas with axis parallel to your x-axis, opening to the right, y minus k squared is equal to 4a times x minus h. Opening to the left, y minus k squared is equal to negative 4a times x minus h. The same is true with our parabola opening to the right and to the left. If the location of our focus is in positive coordinates or in the positive plane, the value of our 4a is also positive. If your focus is located in the negative plane, the value of our 4a is also negative. Another thing that you might want to remember, if your parabola opens either upward or downward, your x term is in the second degree. If your parabola opens either to the right or to the left, your y term is in the second degree. Reduction from general to standard form. The general form of our equation of the parabola is ax squared plus dx plus ey plus f is equal to 0, and your cy squared plus dx plus ey plus f is equal to 0. Let us remember again that if your x term is in the second degree, your parabola opens either upward or downward. If your y term is in the second degree, your parabola opens either to the left or to the right. Your general form has equivalent in standard form. That is, for parabolas opening either upward or downward, x minus h squared is equal to 4a times y minus k. And for your parabolas opening either to the left or to the right, y minus k squared is equal to 4a times x minus h. In your standard form, you will be able to determine the location of the vertex of our parabola given by your h and your k.